At the Daewoo shipyard in South Korea, workers are racing to finish one of the biggest ships in world history. It will dwarf an aircraft carrier, carry enough crude oil on a single voyage to top up the gas tank of every car in Canada, and cost nearly $100 million to complete. The Hellespont Fairfax will be a wonder on the high seas of the world. But there's one big question. When launch day comes, will this supership float? Dry dock number 1 at the Daewoo shipyard in South Korea. The time till launch day countdown is on, as thousands of workers assemble one of the most colossal self-propelled objects ever constructed. An oil tanker named the Hellespont Fairfax. Planned for more than a year and assembled on an 18-month schedule, the stakes are as huge as the ship's propeller. The Fairfax is the leader of a new generation of double-hulled tankers. Longer, stronger, and hopefully safer than anything else on the seven seas. Its dimensions are staggering. At 380 meters from bow to stern, it's as big as 4 football fields. It would be a par 4 for Tiger Woods. A jog around the deck is a mini marathon. And with reinforced twin hulls to prevent leaks and spills, the Fairfax will be strong enough to carry 7 times its own weight in crude oil halfway around the world. The Fairfax is too huge to be manufactured in a single location. So parts were shipped in from factories in Europe and elsewhere in Asia. Putting it all together was a mammoth exercise in engineering, economics, and teamwork. The modern oil tanker owes its existence to our geographical bad luck. We live here in North America, but the oil is there on the Arabian Peninsula. And fleets of hundreds of tankers have been bridging that gap for more than half a century, growing larger as our appetites for energy have increased. And while profit is the reason why a ship this huge is being constructed, environmental protection is behind the double-hulled design. Protecting the world's coastlines from unspeakable disaster is a big responsibility, and the ship's owner acknowledges that there will always be unforeseen dangers.
The rules of the road are pretty clear. However, they're subject to interpretation by the officer of the watch at the time. And if you're in a confined waterway, you're relying on your radar because visibility is poor, and you're relying on your contact with the other ship to see who's going to turn in which direction. With language problems that exist, and with the inability to establish communication very often, accidents happen.
(1989), an accident which caught the attention of the whole world. The Exxon Valdez grounded on a reef in Prince William Sound, Alaska. It was carrying 53 million gallons of crude oil, 11 million of which spilled into the sea and washed up on the shoreline. In 1990, a year after that disaster, government lawmakers insisted all new tankers be constructed with double hulls. An outer hull to take the force of a collision, an inner hull to contain the dangerous cargo. Thus began an evolution in tanker design that has led to the Hellespont Fairfax and challenged ship designers and builders at the world's biggest shipyards. For the Koreans to keep to a very demanding schedule and still maintain their price advantage, they must run an extremely efficient operation. Massive components, like this hull section, are built in many locations and hauled to the dockyard for final assembly. The unit has been built flat on its side. It will take 3 cranes to lift it upright and lower it into place. If a section doesn't fit or doesn't arrive on time, the builder will have to answer to the Hellespont Quality Control Team. Brought in from Europe and North America, this group will stay on top of every single weld, every inch of wiring, every paint job during the 18 months of construction. Their leader is Mike Kennedy, a native of Sarasota, Florida. Mike works out of the Hellespont headquarters in Greece. But until the Fairfax is finished, he will live full-time in Korea.
Anything that's not signed and you're 100% happy that you will live with it forever, then you have to keep it open.
The team includes marine architects, engineers, and even the man who will captain the ship on sea trials.
Okay. Did it fix itself in 5-10 minutes, or always was wrong?
No. He stabilized again.
And then you adjusted?
Yes.
Alright. And was this correct?
Yes.
This was correct?
Yes.
Why you have number 4 here? Which?
Wearing their team colors makes them even easier to spot among the thousands of shipyard workers. Officially, it is a ULCC, ultra-large crude oil carrier. But you could call the monster taking shape in South Korea a big fat Greek supertanker. But building one of the biggest ships in history means confronting some of the biggest construction challenges in history as well. Launching the Fairfax is the ultimate dream of a Greek family named Papachristides. Emigrating to Montreal in 1930, Phyxos Papachristides built a successful business, selling rare postage stamps to collectors. When the Second World War ended, he leveraged his stamp business to buy 9 war surplus cargo ships.
The company was established by my father in 1946 in Montreal. Canada at that time was one of the major shipbuilding countries in the world. And in 1946 my father bought some 10,000-ton tween-deckers and some 4,500-ton tween-deckers, fleet of 9 ships, and that was the beginning of what was called at the time Papachristides Company Limited.
This maritime empire would soon hoist the Canadian flag over a fleet of Great Lakes grain and ore freighters. When the St. Lawrence Seaway was completed in 1959, the company acquired several oil tankers and set its sights on global commerce. By the 1980s, the company, now called the Hellespont Group and headquartered in Greece, saw that its future lay with its tanker operations.
Well, shipbuilding, as you can appreciate, has moved from America and Europe to the Far East over the years because of the cost of labor initially and then the productivity of yards in the Far East. Today, Korea is bigger than Japan in terms of volume of ships built, and they also happen to be the most economical.
To twice the size of a luxury cruise liner, longer and heavier than an aircraft carrier. The world's largest double-hulled tanker is being built for only one purpose: to transport as much crude oil as possible from the wells of Arabia to the refineries of Texas and Louisiana, and then to hurry back for more.
These ships are big ships, and there's only so many places in the world they can go and take a full loaded cargo. The base case scenario that's always examined when we do any design was, could we load in Saudi Arabia? And the prime discharge area that we always considered was U.S. Gulf area.
It will take more than 5 weeks to sail the ship around the Cape of Good Hope, across the Atlantic to the Gulf of Mexico. A shortcut through Suez is out of the question, because fully loaded with crude, it will draw 24 meters and tear the bottom out of the canal. Unloading at the U.S. end will require only a few hours before the Hellespont Fairfax sails back to Arabia, light enough to take the faster route through the Suez Canal. That one-way ticket costs $400,000, but it will shave a week off the return trip, and the next delivery will more than cover the toll. In fact, the Fairfax will earn back its $100 million price tag in just 4 round trips. The Hellespont Fairfax is divided below decks into 3 rows of 21 tanks, each one larger than an Olympic swimming pool. Total capacity is 3.2 million barrels. That's enough to fill 15,000 oil trucks and provide 30 liters for every family car, SUV, and minivan in Canada.
The ship has on board 21 cargo tanks. They're arranged in 3 columns, aft to forward, and they're individual, and they're individual for many reasons, one of which is commercially we can carry many different grades of crude oil. Crude oil just isn't crude oil, it's what kind of crude oil, and we can carry different cargoes in each of the tanks.
The tanks have been designed with a minimum of internal structures, and there is a special coating on the vertical walls to keep thick, sticky crude from clinging, creating potential fire and explosion hazards, and reducing profits. But in case any oil is left behind, special shower heads are turned on from the main deck. These crude oil washing machines, or cows, scour the tanks at ultra-high pressure to ensure that every last drop is offloaded.
What's left is a very, very thin film of oil. The majority of the oil is long gone and out of the tank because of these machines.
Older tankers carry a network of pipes inside the body of the ship. But the designers of the Hellespont Fairfax are placing all the pipes on the main deck, where they're easy to work on and any damage is easy to spot. Best of all, they don't take up valuable crude oil cargo space. The double steel hull, cargo tanks, and piping systems for the world's biggest double-hulled tanker are a triumph of marine design. Now they need to lower in an engine powerful enough to move it. This is not an intercontinental ballistic missile, though it's certainly big enough. It's a spare cylinder for the engine of one of the largest ships in history, the crude oil tanker Hellespont Fairfax. As the final sections of the engine are swung aboard and lowered 30 meters into the hull, Everyone wonders if it will perform as well as it did in Europe, where it was assembled, tested, and then broken down into 5 massive pieces for shipment to Korea. This is the first time a 9-cylinder engine has been installed in a supertanker, and Spiros Alamanis, Hellespont's chief engineer who came to the project from Greece, has been involved with the mighty power plant from design to construction.
It's a 9-cylinder engine, the first of the ones built in order to power this big ship. Similar type engines have been before with 7 cylinders in the market, but for this project the power requirements were much higher, so the maker added 2 more cylinders.
Nine cylinders may be 3 fewer than some high-end sports car engines, but these 9 pistons will generate more thrust than half a dozen 747s at full throttle. With the engine firmly secured below decks, the massive superstructure that will sit directly above it must now be lifted into position and fitted to the ship. An operation that will continue well into the night, keeping to schedule as launch day approaches. With the bridge in place, the engine assembly can be completed. The scale is, well, it's titanic. But the cycle of ignition and exhaust are similar to the diesel engine in a family car. When the enormous cylinders compress the fuel, it ignites on its own, forcing down a piston head the size of a backyard gazebo. To get the giant piston moving in the first place takes a mighty kickstart, a gale force blast of compressed air.
What the compressors will do is they'll force the cylinders to go around, and that will be enough usually to start the ignition process. And then once it starts going, it will go unto itself. But those air reservoirs are to crank the engine, like the old-time pictures you saw of the cars with the crank outside. Well, we have the same thing, but with air cylinders instead doing the cranking for us.
These engines are designed to burn heavy fuel oil. That's one of the heaviest distillates that you can get from crude oil.
That fuel is a thick sludge, barely refined from heavy crude oil. Room-sized purifiers filter out wax, water, and other scum, ensuring a clean burn.
We take out the water, we take out all the heavy solids that cannot be used, and then we heat it up to make it very light, and we have a nice combustion.
The engine is directly coupled to the propeller shaft. No gears, no clutch, no neutral. Unlike a car that can idle without moving, the 380-meter-long Hellespont Fairfax has one gear, forward, and it will keep on moving as long as the pistons are churning. Many large ships have 2 engines and 2 propellers. This giant needs only one, but it's a whopper. At over 10 meters high and weighing in at more than 100 tons, this mountain of aluminum and bronze took 5 days to cool off after it was cast, and 3 weeks of polishing to give it perfect balance. The rudder seems like another work of science fiction. It's as big as a Wimbledon singles court and weighs 228 tons. Connected to a shaft, the rudder is turned to port or starboard by this hydraulic system in the steering gear room. Because of the immense size of the Hellespont Fairfax and the speed at which it is designed to travel, unbelievable forces are exerted on the rudder. One of the biggest steering gear machines ever built is needed to keep the ship on course.
Because of the size of the rudder and the ship speed and the size of the ship, this is very big, and you need about 1,000 ton-meters torque to turn that ship. That's the maximum it can take.
1,000 tons per meter to turn this enormous blade, which is set against the forces of inertia and the ocean. There won't be any sudden U-turns when the Fairfax is at sea. As the tanker gets closer to launch day, Mike Kennedy will sign off on the job in stages. Today, he's measuring the depth of one of the crude oil tanks and finds a variance of 4 millimeters. The strained smiles can't disguise the seriousness of the situation. If Kennedy refuses the job, a whole section of deck will have to come off. If he accepts it, the specs will have to be adjusted. It's a Mexican. Make that a Korean standoff. 4 millimeters over a distance of 3,400 millimeters.
I'll sign for steering it only.
To the relief of the construction boss, Mike accepts the adjusted paperwork. Everything electrical on board has a backup. One of these 3 generators is always on standby. To carry all this power around the ship, 120 kilometers of cable will be installed, every meter of which has to be very carefully insulated. Imagine a raging electrical fire on a ship that doesn't even allow cigarettes on board. Ultimately, all the wiring leads back to the nerve center of the ship, the bridge. In an extreme emergency, the vessel is so completely automated that it could be kept on course by only one person.
For the captain, it's the full responsibility of the ship. I'm responsible for the loading operation, discharging operation, the whole traveling operation. I'm responsible for the security of my crew. I'm responsible for the security of the cargo.
Supertanker captains belong to a very select group of seafarers. Only the best mariners in the world are trained for this job. Captain George Serafiminas has left his family at home in Athens to bring his ship handling expertise to the construction site. The captain and his crew will be surrounded by the very latest in electronic navigational aids. And, of course, each system is duplicated, because on a 38-day voyage across the South Atlantic, the ship is a long way from a repairman or a service call.
It's something very impressive, at least for me.
In the unlikely event that disaster strikes, a complete log of the final week will be on a voyage data recorder, not unlike the black box on board commercial aircraft. 7 microphones placed around the bridge will record every sound, and all the data from navigation, engine room, and even the rudder position will be collected. When the captain is on the bridge, he needs to see everything and anything at all times. No easy job when you're 8 stories above a deck that stretches to the horizon. But 5 television cameras help a lot, giving the captain a close-up look at the most likely places where things can go wrong. Below the bridge and taking up most of this huge structure are rooms for 45 people, 39 crew members, and 6 Egyptian pilots who will live aboard during the careful voyage through the Suez Canal. Incredibly, there's even a small swimming pool. To keep the Fairfax from drifting while holding position near port requires an anchor of monumental proportions. The Fairfax carries 2 such anchors, each one weighing 22 tons, and the chain on which it hangs weighing an additional 150 tons. The colors on the chain tell the crew how many fathoms have been let out. With that much iron over the side, the ship isn't going anywhere. Stopping the Fairfax at sea is a different matter. That 9-cylinder engine will get the Hellespont Fairfax moving at a top speed of 20 knots, or 36 kilometers an hour.
Number 8 cylinder, the temperature is 375 degrees Celsius. Okay.
If the engine suddenly fails, it will take more than half an hour for the ship to gradually glide to a halt.
If the ship is running and suddenly you have no power, then by its own inertia will keep going and the speed will go down. But in a calm condition, we estimate that this would be over 2.5 miles.
Unless it hits something big, like Barbados, Aruba, or Cuba. In the Daewoo shipyards of South Korea, where 20,000 workers complete an average of 1 big ship every week, the launch of the largest double-hulled tanker in the world is getting very close. The Hellespont Fairfax, a ship that demonstrates the advantages and the possibly disastrous dangers of supersizing. Supertankers as a class of ships seldom come this close to land. They prefer to offload at pipelines attached to mooring stations several kilometers offshore.
I'm going to take a line from you through a center lead as an escort there, huh?
Yeah, very good. Then maybe just stand by on the stern here until you're ready.
This giant single-hulled tanker, also owned by the Hellespont Group, illustrates what happens when a supertanker does venture into a harbor. As it slows down, it loses its ability to steer. A tugboat off the stern is there to act as a rudder. If something went wrong and the tanker's single hull ruptured, the massive amount of oil it carries would end the ecological life of the bay for years to come. The double hulls of the Hellespont Fairfax should help to prevent spills. But it's still carrying millions of tons of flammable petroleum across some of the stormiest seas in the world. The list of things that could go wrong is almost as long as the tanker itself. At the top of the list, a possible explosion. If any of the volatile fumes and residues of millions of liters of crude oil linger in the 21 giant tanks, a network of 240 electronic gas detectors called sniffers will be on continual alert.
The last thing you want is a spark in that mixture, but you're going to probably get something potentially is there.
That potential is a spark of static electricity produced whenever a liquid flows through a narrow tube at ultra-high pressure. But nothing can burn without oxygen, and Mike Kennedy has designed a unique system that fills the empty tanks and crawl spaces with non-explosive inert gases. Gases that are a byproduct of the ship's own engine. Cooled by sprays of seawater, the exhaust is reduced to harmless nitrogen and transferred to the tanks.
We've tested it in real conditions, and it works well. We can fill a tank safely with inert gas very fast, very efficiently, very thoroughly, and then when we need to inspect that tank or go in that tank, we can, what they call gas free it, put fresh air back in the tank so people can go inside, and we can do it fast, thoroughly, efficiently, and I think it is a real addition, a new addition to safety at sea.
Another likely hazard is metal stress. This supertanker is a prisoner of its own enormous size. It will strain, flex, and twist in the ocean swells. Metal decks and hull will expand and contract as the ship travels from the desert heat of Arabia to the frigid waters of the South Atlantic. Because double hulls have only been around for the past 5 years, little is known about their long-term reaction to stress. The hulls and the narrow chamber of inert gas that divides them are constantly bending. There is always the danger that something will snap and cause a catastrophe. Along the deck, a series of stress sensors detect movement in the hull, which will alert Captain Serafiminas to slow the ship down or change direction to reduce the strain.
Here is a stress monitor. Can show us where the ship hurts. There are 4 sensors around the deck. We have 3 from starboard side and 1 from port side, the left side of the ship. We can see the stresses at any moment.
It seems like a very simple idea, but what you have is you have a very heavy cargo pressing down on the double hull space. Then you have this gap of roughly 3 meters, and then on the other side you're 20 to 25 meters deep in the sea, and it's pushing up from the bottom. And during the course of a voyage, the ship will naturally flex a bit.
Miles of pipelines on the main deck also are designed to cope with stress without bursting. Non-rigid couplings will bend and flex with the movement of the ship. Below decks, there are more hazards. On every voyage, crew members will have to squeeze themselves between the cargo tanks and the inner hull to check visually for cracks, rust, and corrosion. The job will take 4 men 3 whole days as they wander for miles, caught between millions of barrels of oil, tons of flexing steel, and the infinite ocean. Even the ship's outer surfaces are cause for concern and potential danger. Acres of blinding white epoxy paint on the upper deck are intended to reflect the Arabian sun, while coat after coat of rust-proofing on the hull will fight corrosion and repel the barnacles and other marine hitchhikers that could slow the ship down and cost its owners time and money. Imagine having to spray paint a surface of 50,000 square meters. That's enough paint to cover more than 100 two-story houses. And then when it dries, spraying it again and again and again. 3 coats of anti-corrosive, followed by a bonding coat, followed by 3 more coats. These final 3 coats are anti-fouling paint, which will very slowly wear off, micron by micron, taking with it any marine growth like barnacles and seaweed, which are hitching a ride. Inside the tanks, another monumental paint job. Anti-abrasive coating is applied to resist the corrosive cocktail of seawater and sulfur. Ultimately, even this supertanker will rust. The crews can only battle to keep the Fairfax rust-free for its projected lifespan of 40 years. The rest of the ship is painted white to reflect back some of the desert heat and reduce evaporation of the precious cargo, and white so that any leaks or drips will be easily seen.
And we hope to reduce cargo loss through vapor emission by having a cooler cargo. The differences between white and red are as much as 20 degrees Celsius, so it makes a big difference.
For the crew members who find the acres of glaring white decks hard to take, there will be a special issue of ultra-dark sunglasses. But there's a problem. As workers prepare to apply the final coats of paint, the weather turns damp and foggy. Under these conditions, the paint won't cure properly. Both the builder and the buyer are anxious. The Hellespont team has to get their ship to the oil fields because the price of oil is $30 a barrel, or $96 million a trip. And the Korean shipyard, well, they'd like to get to final delivery and an $80 million payday. The shipyard suggests wrapping the ship in plastic and using giant heaters to keep it warm. Mike Kennedy insists that the paint must cure naturally in the 4 days allotted. This decision backs up more than the completion of the Fairfax. In a shipyard that must complete an average of 1 ship a week, valuable dry dock space won't be available. Mike won't compromise this time. The launch date is set back 3 whole days. With launch day finally in sight, the biggest of the new breed of tankers will begin its working life firmly at the center of world attention. Mike Kennedy recalls that at the keel laying ceremony 18 months ago, a cake was presented to the officials, and in accordance with Korean tradition, pieces of cake were also offered to the gods of the sea. Whether the gods had their cake, and ate it too, will soon become clear. Will it live up to all of the expectations, or will it be a massive miscalculation? Launch day in South Korea for one of the largest ships in the history of ships, the Hellespont Fairfax.
The world's largest double hull at this very moment is a huge ship. It has an overall length of 380 meters. The breadth of the ship, how wide it is 68 meters. And the deck to the bottom, the depth of the ship as we call it, is 34.5 meters.
For 4 hours, water is let into the construction dock until the Hellespont Fairfax slowly rises from its berth. Without ballast, the mighty propeller remains well clear of the water. Launching a ship that weighs 67,000 tons is a slow and careful process, not a sudden splash. There will be no champagne and no sliding down a slipway into the harbor. Since the Fairfax shares its berth with other big ships under construction, they will also have to be rearranged. In some cases, huge bits of ships find themselves prematurely launched. Now comes the most crucial moment of all. To a chorus of ships' horns, the Fairfax floats free. A man-made sea monster finally taking to the sea. It has taken 18 months to assemble the double hull. The 21 tanks for heavy crude oil. The mammoth engine. Propeller, anchor, and rudder. Now, every system needs to be checked out before the maiden voyage to the oil wells of Arabia. The engine will be checked for vibrations at full speed ahead. Pressure and lubricating oils are watched intently. The mighty engine needs a complete oil change every 2 hours. Smoke detectors, bridge alarms, steam turbine pressure, everything is scrutinized. To test the crude oil pumping system, the tanks are filled with seawater and checked for leaks. Next, seawater is blasted through the pipelines. When the Fairfax begins pumping crude in a few weeks' time, this incredible force will be out of sight, safely hidden away, coursing through an oil refinery's pipes in a massive, life-giving energy transfusion.
We can discharge 15,000 cubic meters of cargo per hour, and that involves taking it from deep in the tanks, raising it to deck level, and then along the piping on the deck to about midship where the cargo manifolds are, then out to the sides of the ship, depending on which side is being used or has the connection to shore.
The mechanical force behind this crude oil Niagara is a steam turbine in the engine room. The fresh water for the steam is distilled on board ship at a rate of more than 60,000 tons a day. The Fairfax has the ability to pump itself dry in 24 hours, making it possible for her to turn around faster than most of the world's oil tankers and speed back to Arabia. In a few days, the Fairfax will head for the Middle East. Crude oil will replace the salt water spewing from its holds. But one big question remains. Will Mike Kennedy and his team sign off?
The reason why we built these tankers is because they will carry roughly 50% more oil per trip, and yet our operating costs for bunkers and insurance and crew will only be about, say, 15% more. And this will equate to a savings that can be used both to increase our profits and also give something to the oil companies that come to charter us.
This is the destiny of the Hellespont Fairfax. To travel between the wells of Arabia and the shores of North America in 38 days, feeding our insatiable appetite for energy. And as for the sign-off from the Hellespont Quality Control Team,
the hydrodynamics of this vessel had been great. It was even beyond the shipyard's expectations. And they go fast, they're efficient, they can turn nicely. It's just beautiful.
The whole thing has been fascinating. I've waited 25 years to build a ship. It's big, it's powerful, and we've had a chance to put a lot of innovations on. This is not only just a ship, it's a super ship.